So today what we are going to talk about is we're going to start our session with the tuples. So tuples are, what are tuples? Anybody familiar with what tuples are? No? Okay. So tuples are very similar to lists. The difference is that lists are mutable, so you can change them, whereas tuples are immutable, so cannot be changed. So once you create a tuple or tuple, whatever value you have in there, it actually stays that way. And the difference is that when we are looking at a tuple, it started with the parentheses instead of the square brackets. So they are kind of used, they use parentheses to actually define that this is a tuple. Now, one other thing that you have to keep in mind is that with the tuple, if you just have one element in the tuple, it is always followed by a comma after that. So if you do not have a comma after that in the tuple, it's going to give you an exception or an error, because tuples are kind of, if there is only one element in there, it does require a comma for that. But let's see what do we mean by mutable or immutable? Anybody, any thoughts on that? And this is the notebook that I was working on Thursday. So anybody, what's the what do you think when we think about mutable versus immutable?
Being able to append and remove values would be mutable or changeable.
Correct. Very good. So remember last session when we had this list of cars. Now all right, so when we had this list of cars, so let me call this list cars. And when we have this list of cars, if I want to change, so the second element should actually have been Ferrari, because that was the car that we had in there. However, for some reason, I created that list here and I just copy pasted, and I did not have that Ferrari as a second car here. So if I wanted to change this element and make this element or correct this element, I can say cars and then the index. So the index for the cars here is 0, 1. So the index is 1. So I can say index 1 is equal to, and then I can go and say Ferrari. And then when I run this, it will actually go and change that value of cars and make this a Ferrari. And similarly, we can do it for index 2 also, because the index 2, the car was McLaren instead of defacinatrate. So we can actually just go and change that element by appending that list. So this is what happens with the list. However, if we define a tuple, now this is a tuple, and it starts with parentheses, ends with parentheses, and we define a tuple called buffet. And in the buffet, the first element is, sorry, not the first element, but the index 1 is beef. And for some reason, you want to change that to something else. So just like how we did it in lists, if we try to make this chicken, and we run this, it gives an exception that you cannot do assignment in tuples. Because this is a tuple, so we are unable to change that value. And so this is what it means that these are immutable versus lists are mutable. Now, if we wanted to add a car to this, this list of cars, one of the ways of doing it is we can actually say cars.append, and then we can add Audi to it. And then when we run this list, it allows us to, or it adds Audi to the end of the list. Now, if I do the same thing here for buffet, and I want to append, for example, salad to the buffet, again, the same that you cannot append, has no attribute append. Again, you cannot change. So this is what it means when we say that these are immutable. So everybody's good with that? Any questions? Okay.
I believe you had said with the syntax for lists, usually wants to put a underscore before the name. Is that the same for tuples? Do they often represent it with an underscore?
Okay, so what I was trying to say was that when you are naming a list, you should try to name the list so that it makes sense. Now, if there is a pre-reserved word or a function that is already built, if you name it the same, there is a chance, no, there's not a chance, you will overwrite that built-in function. So what I'm trying to say is, there is this function called print, right? And if I define a list and call and name the list print, if I define this and if I run this print, which is the built-in function, will get renamed and it's not going to print anymore. So in order to avoid that, if you think that for some reason this word might be a pre-existing word or something that's already a built-in function, you should start this with an underscore to differentiate it.
Okay, so it's really only if you're concerned it's already a reserved word or used for something else.
Correct. And
okay.
Yeah, and this word list is actually a built-in function. So you see, when I do that, the first thing that comes up is that it's a function.
Okay.
So
All
that's
right,
why
thank you.
I named it underscore.
I understand. Okay, thank you. That makes sense.
Yeah, no problem. So the question I have is, if lists, if the difference is just mutable and immutable, and most of the times we need to change things, why do we have two different structures? What is the benefit of having tuples when we can do pretty much everything in the list? And list also allows us to change it, because we would most of the times require things to change it. It's not static. Actually, this might be the second question. The first question I want to ask is, what could be a good use case for tuple? Why would we need a data structure that is not changed, or that we do not want the option to be changed?
My guess would be mainly that's just to have a constant, so that we don't have to, so that nothing changes. Sometimes in a program, you don't want anything to be changed. I guess that's the best way I can explain it. I don't know any other way other than you just don't want it to be changed and you want it to be a constant.
Yeah, but give me an example if you can think of any example. Okay,
I don't know. I guess
me...
you could use this in an algorithm, like maybe like a password or something, instead of like you'd have to change the password. Instead of creating a new password, you'd just have to create a whole new tuple. So it just prevents like user error or like anyone going into your program trying to
Sure.
change something, just makes it more difficult.
Sure, that's a good use case. You can actually save passwords.
I was basically going to say something similar, which was that when you don't want the user to be able to change the values, like in a video game, if you had changing characters or colors, you could have the user able to change those. But if you have something that you need to be set and not changed on the user side, only modified within the internal functionality, then that way it would prevent the user from having any access to changing it.
Sure, yeah, and those are good use cases. So here are a couple that I would like to highlight. When you define months in a year, January to December, do they ever change? If you have to define how many days are in a month, besides February, nothing changes. If you have to define weeks, days in a week, they don't change. Coordinates of maps do not change. So those are some use cases, and my use case, the use cases that you guys gave are absolutely great use cases, and they all work. The one that I am kind of sharing, they are more like data analytics, data science related. So I just wanted to kind of differentiate. I wanted you guys to think about that side also, because in data science, we are dealing with time, and we are dealing with dates, and we are dealing with days, and that's important for us, and we don't want it to change. So Tuple could be a good use case for them. Does that make sense? Okay, so that's one thing. Now, you guys kind of answered that question a little bit also, is that you want the user not to change, not be able to change it. So that's why you could put it in tuples, which is true, and that most of the times if you want something that cannot be changed by anybody by mistake, not even intentionally, somebody just changes it because they were trying to do something else, and it's changed the value there. Another example could be the value of, I think if both of you have taken math, or Eric, if you have taken math also, like they're constants like pi. Pi is already 22/7. You never changes. You put it in a tuple because you don't want anybody to even change it. So those things. So that's one advantage. But the main advantage of tuples over lists is tuples are memory efficient. Why are they memory efficient?
Is a list in Python kind of like an array list where basically it changes size, it's not a fixed size, and so therefore to iterate through it, it uses the higher processing power?
Right. So yes. So it's basically like an array list, and for a list, because you need it, you need the ability to actually be able to change things, and the ability to append things and remove things. Whenever you're allocating memory to a list, and your list requires, let's say it requires 1 kilobyte, you would probably allocate 4 kilobyte for it, or 3 kilobyte for it, so that you can actually have the user be able to append to it and keep it at the same place. So you need more memory for it. Whereas tuple, nobody's going to change it. It doesn't change. So if you require 1 KB, you give 1 KB, and it's more memory efficient. And that helps them actually do processing fast also. So it's one of the main advantages, or one of the advantages is that it actually allows you to save memory and process the data quicker. Yeah, go ahead, Kyle.
So just a quick question. So whenever you're dealing with variables that are able to be changed, your computer is going to allocate a little bit more memory, so it's able to append and add things without having to go in, I guess, and add more memory for it. That's the way it is for all variables that are able to be changed, and then all variables that are constants, they don't allocate more memory. That's just my question.
Yes. So if there is
like for all programs.
Yeah, so if there's a data structure that actually allows appending and removing and adding those kind of things, usually your program or your computer is going to allocate a little bit more memory so that it can actually keep everything together. Otherwise, it will have to start. And again, it can do that. It has to start creating pointers that, okay, half of the list is here, and the other half of the list is in that part of the hard drive, and the third part of the list is in that part of the hard drive, and there is one element that's in the fourth part of the hard drive. So it has to start adding those pointers. Whereas if you give a little bit more memory, you can actually most of the times fit stuff at the same place.
That makes sense. Okay, thank you.
Yeah, no problem. All right, good questions. So
Sorry, I just wanted to clarify real quick, trying to remember. Are both lists and tuples capable of holding multiple types of data within the same structure?
absolutely. So you could actually have a tuple, even have a list inside a tuple. So this buffet is one of the is a tuple that I just created. So let me make this salad a list, and it can store I should actually just do it right here. So you see, it can store a list within a tuple. And if you want to have a different structure, like an integer, instead of that, it can store an integer. So they can store multiple types of data types.
Okay, that's very handy. Thank you.
Yeah. All right. No other questions. All right, let's go back to our presentation here. So these are tuples or tuples. All right, so this is an exercise for you guys. So just like how we did that earlier exercise where we added something to the list, use a for loop to print each element of this restaurant offers. Try to modify. So we tried it. If you want to try it, you can try that. I want you guys to think outside the box. Think outside the box, and if the restaurant wants to change, so they have defined this as a tuple. If the restaurant wants to change, so maybe add lamb to it, or something like that, or any other like veggie or something. How will they do this? If they wanted to add, like there could be a time where you need it to change for some reason. How will you change this? I want you guys to think a little bit outside the box for this third one. The first two are fairly straightforward. The third one is, I want you guys to think about a little bit outside the box.
Is there a in Python, is there a way of saying basically like the next element as I'm doing the loop to make it actually go through each one?
So instead of iterating over the index, you want to actually call the next element in that list. Is that what you were?
Yeah, because basically I can print the entire list, but if I'm wanting to do it in a for loop, I'm not sure actually what term to use to just select each element individually in a print function.
Okay, let me just try to understand what you're saying. So you're saying that if this is the list, you want to select each element inside the list individually?
Oh, okay. I see actually there. I use the term that I created. So for food and buffet, then I would print food. Okay. Sorry, I had forgotten how to do that.
That's okay.
I also have another question. Okay, I see actually the difference. So a list uses brackets and the tuple uses parentheses. And so that's how it knows whether we're creating a tuple or a list.
Correct.
Okay, okay. All right, thank you.
Yeah, no problem. But let me kind of talk about that a little bit so that you guys understand a little bit more about how Python works. So this is our data structure buffet, which is a tuple, right? I can take this buffet, and I did talk about that function called list. I can take the tuple and convert that into a list. Once I convert that into a list, I can change any element. I can call this list buffet, and Okay. So this is the list of buffet, and then when I want to actually convert it back to a tuple, so it becomes a tuple again. So you can actually take elements of a list type, convert it into a tuple, and tuple back into a list. So with this list buffet, you can actually say that, okay, for index number 0, instead of chicken, I want to make it fish. And then you change it, and then you make it, the first element is a fish now.